So just say beyond the standard, single zone mini split system where you have one outdoor unit and one indoor unit maybe mounted on the wall. What other types of ductless configurations are available, and can they handle things like multi-story homes or large open areas that people have in their modern homes now?
So you have basically for outside condensers, you have two types, right? One's a single zone condenser. It can only feed one indoor unit inside the space. And then you have multi-zone condensers where you can feed multiple indoor units inside the space, or I should say you can power multiple indoor units inside the space, up to 8 for the manufacturers that we work with, on, again, that one condenser outside. And then as far as indoor units, there's a whole range of options. So most common you see is we call it a high wall mount unit. That's the most common you see. They mount up high on the wall. They mount right to the drywall or whatever is the finished material on that wall.
Right. Usually maybe up above a window or just above your mantelpiece on the fireplace, or something like that.
Exactly, high up on the wall. And then they have, as far as wall mounted units, they have one other style where we call it either a low wall unit or it can be set right on the floor, a floor unit. So that looks something more like a radiator, and sit low on that wall or on that floor. Typical dimensions for that is like 30 inches wide by 24 inches tall. That would be the other wall mount unit that we would use. Separate from that, we have ceiling cassettes where the units get recessed up into the ceiling if the ceiling is a flat ceiling, right? If it's a flat drywall ceiling, something like that, we have units that we can recess right up into there. That
Like they actually are made to like fit in between the ceiling joists, right?
Yeah, so one manufacturer we use, they have like they call it an easy fit ceiling cassette designed for typical 16-inch on center ceiling framing. So there's no real, if you're using those and your framing is typical 16-inch on center, usually there's no real modifications of the framing, which is nice. We could just cut the hole in the ceiling and recess it up in.
Okay. Otherwise, with like a larger unit, you might have to do some reframing to like create a box to put the system into.
Yeah, if you're using another form of ceiling cassette that is, like a 2 by 2, 24-inch by 24-inch, usually the framing is not gonna allow for that to fit up in there, unless we have used those. Say you have a basement with a 2 by 2 ACT ceiling, drop ceiling. Those 2 by 2s actually they fit into the ACT ceiling grid pretty nice. You could take a tile out and put that right up in, assuming your height above the ACT ceiling to the framing is enough to fit the unit. So that's all for ductless indoor units, right? But then they have it's kind of it's a weird way to say it. It's a ducted ductless unit, if you will, or they have air handlers that you can stick in maybe a basement or an attic space and have actual ductwork coming off of them in ceiling registers or floor registers into the finished space. So those have the ability to be connected in combination with ductless units and head back all to that same outside condenser.
So maybe would a disadvantage of those ducted units though be, that they're all running off of one unit? So can those rooms that those are hitting only be set at like one temperature? You can't have individual temperature control. Like say it was in an attic and then you had 3 bedrooms on a second floor and that ducted unit was handling all 3 of those bedrooms. You're going to only be able to set that temperature for one temperature setting. Is that correct?
Correct. Yeah. So if you're in a situation like that where you have 3 bedrooms and you're doing an air handler or a ducted unit in the attic, you'd have one thermostat controlling all 3 of those spaces. So it does take away from your individual temperature control of each room. But what it does sometimes allow is if those rooms are small rooms, they may be too small for even the smallest ductless unit to go into that room. So it's a good way, that system is a good way to size properly when the individual rooms are too small for say a 6,000 BTU ductless unit, which is the smallest that you typically see out there.
Right. And why is it that you want to be careful about that sizing?
So the sizing would be important so we don't overcool the space, overheat the space in the wintertime is common. And then we don't want to cause any sort of short cycling where the unit's coming on and shutting right off and coming on and shutting right off. So those would be the three real major concerns with oversizing a room. And sometimes if you say you have a 100 square foot room, that unit, that 6,000 BTU ductless unit would be too big for that space.
So for these multi-zone systems, where you said you have one outdoor unit that can handle up to 8 indoor units, do you still get that individual temperature control on those 8 indoor units? You could set each one of those for a separate temperature.
Yeah, exactly. So say you did have 8 indoor units, you'd have essentially 8 zones where you can set individual set points. What you cannot do with the residential equipment right now is have some units heating while some units are cooling. So the system cannot heat and cool simultaneously.
That would be pretty rare, though, right? I mean, it maybe possibly like in those spring and fall days when it's you might have some odd places in your house where it's like, oh, this is kind of cold in here, and then maybe a sunroom where it's a little hot or something like that. That would maybe be the only situation, but it's pretty rare. It's mostly like, okay, it's 40 degrees outside, now it's going to be heating, or it's 80 degrees out, now it's going to be cooling. It pretty much goes by the outdoor temperature.
Exactly. So, but once you're all in heating mode, you can have any heating set point you want. All 8 zones can be different.
How does it work with, like, a large open area? Like a lot of modern homes have, what they might call a great room or an open concept or something like that, where you have like a living room and maybe a dining room and a kitchen all in one big open space. Can that all be handled by like one indoor unit, or do you typically put a couple of different units in those spaces?
So, I mean, that would depend on, again, I would say if you can size the room accurately with that load calculation, then and you can cover that load that you calculated with one indoor unit, and you can get the air moving around the entire space with just one unit, then yes, you can cover that space with just one unit. It's all about getting the air though to where it needs to be.
Right. So if your room is like 30 feet long or something like that, it goes across the whole width of the house, and you have a unit on the wall on one end. You might not be able to get that coolness or that heat to go all the way down to the other end of the room. So that's where you might possibly need to have a couple of different units.
Exactly. You might want to split that up into two smaller ones instead of one larger one. Or you might find that if you have the one larger unit, yes, you get enough capacity, but you're needing to run that fan at a very high speed in order to get that air to travel all the way to where it needs to go. One thing we do that's really helps us out when we are doing one unit for a larger space is we'll install a remote thermostat on that unit to sense temperature maybe on the other side of the room. It creates a more even feel throughout the whole space instead of just having the unit sensing temperature where it is. We move that thermostat to where the unit is not, and now we're kind of that unit is working harder to maintain the temperature farther away from it, so it creates a more comfortable feel.
What about the heating capabilities for colder climates, like here in Massachusetts or New England? We don't get super cold, but in the winter we do have some days when when it gets down into the teens or single digits, or possibly even below zero in a couple of days, and in the winter. Are the modern ductless systems able to handle those types of colder temperatures in the winter?
Yeah, I would say absolutely. So there's two types of heat pumps, if you will. Ductless units are heat pumps. There's two types of heat pumps: a standard climate heat pump and a cold climate heat pump. So standard climate heat pump is going to work excellent in air conditioning, and it's going to work great in heat on those shoulder seasons. But if you look at the performance data, they're really going to start to lose heating capacity, maybe below 30 degrees or so, below freezing. a cold climate heat pump is still an excellent air conditioner, but it's designed to give you more heat at colder outside temperatures than the standard. So the manufacturers we work with, they'll produce 100% of their rated nameplate heating capacity down to, I believe it's 5 degrees outside air temperature now.
So that means that like if it's a 6,000 BTU unit, you're going to get that full 6,000 BTUs down to 5 degrees.
Absolutely, yep. And one of the manufacturers we work with even has a unit now where it's full heating capacity down to -5 degrees Fahrenheit. So extremely cold. And just to give you a sense of the average winter temperature here in New England, when we do our manual J load calculations, um, Air Conditioning Contractors Association recommends a design temperature of 13 degrees outside air temperature. So, those units are well rated at 100% heating capacity, well below 13 degrees, where in 13 degrees is what we're told to design our heating systems for. So, the technology is there to be the sole source of heat for the house in New England, as long as you're, making sure you're weather tight and you got your insulation up to par.